Good evening, and thanks for joining tonight's TI Technology webinar, hosted by Texas Instruments, where it's getting close to the end of the year. That means AP exam time, and so we're going to help your students strive for that 5 tonight on the AP Pre-Calculus exam. My name is Mike Houston. I'm the moderator for this event, and I am tonight proud to have with us Karen Slino and Katie Martinez. Karen's a 32-year veteran high school teacher in Flushing, Michigan. She's taught AP Calculus for 26 years and AP Pre-Calculus for the past 2 years. And prior to that, another 25 years of traditional pre-calculus. Karen's been a consultant for the College Board for the past 9 years and is also excited to be one of our T-Cubed regional instructors. Karen's primary focus is teaching is to allow students to experience the mathematics before filling in the gaps. She is the new recipient of the Presidential Award. So Karen, congratulations on that. And in her free time, she enjoys attending Broadway shows, dining at fun restaurants, and reading books to improve her teaching skills. So Karen, thanks for joining us tonight.
Thanks so much, Mike. I'm so happy to be here.
And Katie's in her 22nd year of teaching high school math and is a T-Cube national instructor out of San Diego. This year, Katie is teaching Integrated Math 1, Integrated Math 2, and AP Pre-Calculus. Technology has enabled her students to visualize mathematical relationships and make connections across the curriculum. So Katie, it's great to have you with us as well.
Thanks for having me. I'm excited to be here.
All right, Karen, what are we going to do tonight?
Okay, well, thanks for all the welcome and introductions. Glad to see so many people in the house tonight. It is AP exam time, and we're all thinking about how do we get our kids ready. So we would like to take a focus tonight on how can the calculators that TI provides us help kids to do better on the AP Pre-Calculus exam. So we're going to first talk about some specific skills. Then Katie will talk about FRQ1 and how you can use the TI-84 to help kids to do better on that sort of question. She'll also address a few multiple choice questions with the TI-84. And then I will take a look at FRQ2 with the TI-Nspire and how we can use that to help kids visualize the math. And then I'll do a multiple choice question or two. And then we're having the webinar drawing.
And Karen, what about the outcomes?
Okay, well, tonight we are hoping that by the end of our webinar, you will be able to use the TI technology to really visualize problems and its possible solutions, to connect verbal representations with graphical images, to construct various tools using technology to solve problems, and to explain your results in the context of a problem.
Awesome. Thanks so much, Karen. Tonight we are going to be using that chat window to send general messages. It's also a great place. If you have any questions for Karen or Katie throughout the webinar, use that chat window. Let us know what your question is, and we'll do our best to get those questions answered live. As a reminder, the session is being recorded, and we'll provide you with a link for the certificate of attendance, as well as a link for the documents at the end of the webinar. So Katie, feel free to share your screen.
All right, thanks, Mike. Well, we're very excited to be here. We're excited to share our knowledge with you all tonight. Sorry. Right. And so tonight we're going to start by looking at what are those calculator skills that we really need to know, that we need to be solid with. Hopefully we've been incorporating them into our teaching practices and our students' work throughout the year. These are going to be embedded into both multiple choice questions. There are 12 multiple choice questions on the calculator section of the AP exam, as well as the first 2 FRQs, which is the reason why we're going to focus on FRQ 1 and 2 tonight. So as you can see here, we're going to be focusing on lots of different things: storing and recalling function equations, calculated values, using the intersection tool and the zeros tool of our graphing calculator, finding regressions, using those tables of values to determine types of functions, so looking at some differences in their outcomes, and obviously graphing and looking at how do we adjust our viewing window and how do we use the power of that visual calculator, the visual graphs, to help us analyze a problem, answer a problem quickly. We are really gearing tonight towards getting that 5 or striving for that 5 on the AP exam. So we are looking at testing strategies and how do we optimize our testing abilities and maximize our time and our effort while we're in that testing strategy. So let's move on here. We're going to start talking about FRQ1. And we've picked out for both of these FRQ1 and FRQ2, we've picked out some of the parts. So just so you know, we're not going to go through the entire free response question. We are just going to pick out different parts of it to focus our attention on tonight. So FRQ1 is a non-contextual problem. It's going to be involving units 1 and 2 of our AP Precalculus study. As you can see here, we have 2 different types of representations. This example has a table and a graphical or a equation of the graph for g of x. Sometimes we'll have a graph given instead of a table, and it's going to ask us to involve and connect these concepts together. So right here, question A1 has a lot of verbiage to it. We are definitely going to be finding the value of a composition. And so what you can see there is I've circled the composition that we're doing. We're going to figure out what the value of g of f of x is, and that's defined to be our h of x function. And we're going to find that value when h is evaluated at 5. One other thing to point out is that it does ask us to show work. So if you taught the course last year, that comment wasn't in our directions. So our students need to make sure they show work that leads to their answer this year. We also need the students to make sure that they're giving a decimal approximation. And sometimes if we're working in a fraction mode of a handheld, it'll spit out a fraction answer. So I'm going to show you a shortcut here in a minute of how to tackle that. So first thing we need to do is understand that our input value is a 5. And so if I look at our table, we can see that when our input is 5, we do get output of 34. So now, how do we use the graphing calculator? How do we quickly incorporate this into the FRQ so that our students can maximize their time and be able to move on and have more time for FRQ2 or more time to go back and review their answers to those 2 questions? Well, that function g of x, that rational function that we see there, is going to be used in multiple parts of this FRQ. So what we're going to do right off the bat, and what I've been teaching my students, we started our review today in class, is that right away when you see FRQ1, I want you to put this function, whatever the type of function is, into your graphing calculator. I'm showing this on the Nspire, on 84, excuse me. You could do the same type of thing on Nspire. And Karen will show some function notation on Nspire in a little bit. So if I press the y equals button, we have our y1, y2, and whatnot. We're going to put that rational function in y1. Now we do have a shortcut here on our 84 with the fraction template. We can also get to that another way. I notice that this one's in green, so I'm going to press the alpha button first and then our independent variable button. And so now I'm just going to type in that function real quick. And make sure you always arrow out of the exponent when it's higher, when you're using that exponent key. That's one thing that my students often forget to do. And then they start typing everything, the minus 14x, the minus 27 in that exponent, and it totally messes them up. So just a little habit there, anytime you're using the exponent button above the division symbol, make sure you arrow to the right to get out of that exponent. So I have that function defined in my y equals. Now, I'm not actually going to look at the graph on this question because I don't need it for part 1. What I need to do on part 1 now is to use that defined function to just go ahead and evaluate it. I need to recall that function. So I'm going to go back to my main home screen. I will need that function later in the FRQ1. So that's why I want to put it in there from the start so I don't have to go back and forth. And so I'm going to just press second mode and quit back to my home screen. And I'm going to recall that function definition. I defined that rational function as y1. The shortcut here, and there's various ways to get there. You can get there through your vars button, but I personally like the shortcuts. And I start my students from day 1 of the class using the shortcuts, and that's alpha trace. And you can see we've got these little soft keys. I'm going to go ahead and select y1. And on the home screen, on the calculator screen here, I'm just going to evaluate it at that 34. And Now, right now, if I was to press enter, because my function is defined as a fraction, it will likely spit me out a fraction. So if I press enter right now, oh, this one didn't do it. My other graphing calculator did, and my students had the same issue the other day. So what I try to get them to do, just to make sure that we're all on the same page, is that before they hit enter, they just put a decimal after that 34. And then they can press enter. They can close their parentheses or not. It'll definitely give them the decimal approximation. As a reminder, we do want our students to be rounding to at least 3 decimal places, so at least 3 digits after that decimal, so that they can get that credit for that answer. So for part 1 and FRQ1, we're really utilizing just the recall function of the function's definition. And that can be used anywhere. That can be used in the free response questions. It can be used on the multiple choice calculator questions as well. So it's a really handy thing to use. When we go on to part B, as I said, we're going to skip a couple of the parts because these graphing calculator problems aren't necessarily used for every little piece, and that's okay. Here's part B, or at least the first part of part B. This time, same function, you can see it's the same rational function. It asks us to find all values of x as the decimal approximations for which g of x is equal to 3, or indicate that no such values exist. So if you were to see this as a student, what kind of approaches in the chat, what kind of approaches do you think students might use? So if this was your question as a student, you've never gone through this with them, what kind of things might they do? Awesome. I'm seeing some really great ideas. I'm seeing some people suggesting to put that g of x equals 3 as the y2. I'm seeing other people saying looking at a table of values, using intersections. Students might, you're right, Beth, students might substitute the 3 in for the x. They may misunderstand what that is. So yeah, there's some good misconceptions that can absolutely happen. And so reminding our students that g of x is representing all of those outputs that have a value of 3. And so because we are on a graphing calculator, because we want to maximize how much time we have and not get bogged down on the algebraic skills, because the first time my students ever saw a question like this, some of them immediately went to the algebraic work. And this could be a very, very challenging problem to solve algebraically. So we want to constantly, as we're reviewing for the AP exam, remind our students, we have the power of the graphing calculator. Let's utilize it to its fullest. Let's maximize our time. Let's minimize mistakes, because that's a place where we could definitely get knocked down in points. So we are going to utilize that graph. I'm going back into my y equals and y2, just like I saw some suggestions. I'm going to put in that 3, and we are going to use the intersection tool. Now, my graph, if I know some features about this graph, the graph may not fit very well on my screen. And honestly, I don't know necessarily what my window is like right now. I usually will tell my students, do some sort of zoom of their choice. Zoom standard or zoom decimal tends to be my students' particular favorite. I'm just going to press my graph button, and I may or may not be able to see everything. And it looks like I was able to see everything on here. I do know that I have all my pieces, quote unquote pieces that I need, because my knowledge of rational functions tells me that I have a vertical asymptote at x equals -2, which it does look like there's probably something going on right about here on my screen. It also, because I know information and I've got good knowledge of these rational functions from Unit 1, I know that if I compare these leading terms in the rational function, that I have an oblique asymptote that's following the path of y equals x squared, which it kind of looks like, at least on this right side, sort of looks like this end behavior, if you will, is following the path of that parabola or y equals x squared sort of motion. So I don't necessarily need the whole rest of the graph. Would be nice to see it, but I definitely have this end as x is going to -infinity. So we're talking about those limits. We're talking about another part of FRQ1. The limit as x decreases, or goes to negative infinity, this left side is definitely following that parabola motion. So I do see a good image here. Now, I want to always talk about my students as we're preparing for the AP exam, talking about those features, having us think about how are we seeing everything we need? Because if I didn't see an appropriate window, then I would definitely need to go adjust my windows so I can see and make sure I have all the intersection points. So back to what I was trying to do, intersection, second trace, and we're going to go down to number 5, which is intersect. And I'm just going to use my arrows and I'm going to move my cursor until it's near that intersection point. It doesn't have to be exact. I'm going to select enter for that first curve, which is the rational function. It automatically takes me to that second curve. And that second curve in this case is just the horizontal line at g of x equals 3. So I'm going to press enter, and I just press enter a third time. I tell my students, don't even move your cursor. Just as soon as you're near that intersection point, enter, enter, enter. Speeds it up, and then we need that 3 decimal places. All right. So we were able to quickly get an answer. We did have to think about those features just to make sure we did have that whole graph. And that way we know that we have all those intersections between our rational function and the horizontal line. And so those decimals right here at the bottom, 4.875 would be our answer there. So as we're reviewing with our students, think about not just how are we answering this question to be efficient in our time, but what kind of other mathematical concepts can you bring back to life? My students honestly have probably forgotten most of units 1 and 2 at this point. They haven't seen that stuff in a long time. And so these ideas of what are the features of the rational function, this gives a nice visual of it. We can see that we have these limits surrounding the one-sided limits surrounding the vertical asymptote. We can see that we have some sort of non-linear asymptote. Definitely not a horizontal asymptote, since that degree on the numerator is bigger than the degree in the denominator. So it gives us those ideas and those options, or those times where we can discuss those concepts and bring them back. So even if a question like this, asking about the different features of the function, if it was on the non-calculator questions of the multiple choice, they've heard those concepts come to life. All right, the third part of this first FRQ that we're going to look at is dealing with the table. And this time, and like I said, we're skipping here to question C. This part of the FRQ, because we're given a table, we're able to ask the question about what type of function would best model it. So looking at that table in the chat, what are some things that you notice about that table of values? So in the chat, what are some things that you notice about that table of values? Good. I'm seeing some conversation about it's increasing, and I would ask my students, are our inputs increasing? Are outputs increasing? Are they both increasing? I'm starting to see some really specific verbiage, equal width interval, input intervals. I love that phrase too, Stephen. Trying to train my students back to using it as often as they can. Inputs are over equal size intervals. Good. Second differences are equal. All right, good. I see a comment there that at x equals -2, g of x is undefined. Oh, sorry, that was back to the graph there. But if we look at this table right here, we would have to definitely do a few calculations to figure out or to look at those differences. So when we're asked, and this is the follow-up question to part 1, is the why do you know, or why justify? So remember, we want to think about those verbs that we use with our FRQs. Justify your answer. Justify how you knew it was one of these 4 types of functions that you see in the question. We do want our students to use the verbs or use the expressions inputs and outputs and things of that sort. So we do have equal length intervals for our inputs. Our outputs, right now, we may not be able to see the differences. And so we would need to do some calculations. Now, my students have gotten really fast at using tables over the course of AP Pre-Calc. So that's what we're going to use here. And this is something that they could use as they're practicing or even doing some sample problems to get ready for the test, even if it's a non-calculator type question, because I want my students to be able to justify even if it's not on a FRQ question. So in this case, I already know my X values, my inputs are equal length intervals. I'm going to focus on those outputs. And so in my stat list here, I went into stat and I went into L1. I'm going to just put in those outputs. And so I'm going to type those in real quick. -10, -5, 4, 17, 34. And so my students, as they notice this, most of them have ruled out the fact that we are not multiplying by a common factor. We don't have proportional outputs, if you will. They have noticed that there's not that constant multiplication anywhere. So they are able to rule out 2 of those answers very quickly. And I point this out, even if you may not use a table on this part of the FRQ, a table is a really valuable option to revisiting concepts. And as we're preparing our students for any type of question, multiple choice or FRQ, calculator, non-calculator, bringing out those visuals, allowing our students to access without making errors in their computations and making those connections. So I'm going to go up to the top of L2, sort of like our formula cell, and I'm going to do our differences. I'm going to figure out those differences here. So the way we do that is we press second stat. You can see in blue it says list. I'm going to go over to operations. I'm just going to right arrow. And number 7 down here says delta list. And so what it's going to allow us to do is find the differences or the first differences of that list. I just need to tell which list to find the differences of. So I'm going to press second 1 to put in L1, and I'll press enter. And so now if you look at that L2 column, where my cursor is right now, what do you notice about the differences? So I just saw there's a constant second difference. So that means that they are changing by the same additive value. They're positive and increasing. Good. The fact that they're positive and increasing could help us on other questions. If we are talking about multiple choice, for example, sometimes we're asked the type of function based upon the average rates of change or the change in the average rates of change, or we're asked about concavity. So noticing that these are increasing because our inputs had a difference of 1, we're really looking right here at your average rates of change. So this has a pattern to it. We're adding 4 every time. So if we add that common difference, what we just noticed is that the change in these consecutive values, the change in these consecutive equal length intervals, if you will, is a linear function. So when we ask our students to explain why they knew is quadratic, we want to go back to what that CED says. We want to talk about those input intervals. We want to talk about the equal length input intervals. We see that our X values are increasing by 1. They have equal length intervals. We want to talk about the change in these outputs being modeled by a linear function. Over the consecutive intervals, we get a linear function that can model those outputs or the difference in the outputs. So with FRQ1, we're able to quickly touch on the graph. We're able to quickly touch on using the function's definition to evaluate it. We were able to use a table to bring out some of the features, such as the differences, and seeing that linear pattern, we were able to talk about concavity. And if we wanted to go back and revisit concavity and those average rates of change, since this L2 right here does represent my average rates of change, since my X's or my inputs are increasing just by 1. I can see here, because the average rates of change are increasing, this would be a concave up part of my function here. or the whole function since it's quadratic. So we're going to kind of switch gears now. Look at a couple FRQs before we go in. Sorry, look at a couple multiple choice questions and how the 84 can help us to quickly solve them. So this is coming straight from our CED, and it's pretty wordy. So as you look at that, what kind of misconceptions do you think your students might run into when they see this problem? So you can see here we've got temperature in degrees Celsius in a city on a particular day. We have a function t of t, and it's a very large function where the lowercase t is measured in hours from 12 p.m. from 2 to 9, including those two values. And our goal is to figure out how many hours did it take for the temperature to increase from 0 to 5. So I'm asking about what misconceptions your students might see. So I see Kendra said they might plug 0 and 5 in for the lowercase t. Absolutely. They could struggle with finding the values of the independent variables. Yeah, there's a lot of t's going on. So we need to help our students understand that our input is our time, our lowercase t. Our output is our temperature. And so here we're looking, the question is asking us how many hours did it take? So we're looking for the difference in our independent variable when we have an increase in our dependent variable or our output variable from 0 to 5 degrees Celsius. So our graphing calculator can quickly help us with this. So just like we did at the start FRQ1, we're going to go ahead, we're going to put that massive function, and I'm just going to clear these two out so I don't accidentally have something in there. We're going to put those two functions, or the function, into our graphing calculator. And if I think about that problem right there, again, just make sure you arrow the exponent. If I think about the problem, it actually gave me a really good domain and range to focus on. So if you look at that problem, what is the domain and the range that I want my students to be focusing on? So while I type this in the chat, if someone could tell us, what is the domain and the range that we're going to want to focus this graph on? I don't want to have to fumble with my window because it actually tells me in the problem. Awesome, yes. So thank you, Sherry. Domains 2 to 9, including those values, and the range is going to be 0 to 5. Definitely. Now for my students, I always have them go a little bit beyond in each range and domain values so that we can see a really good window. We could certainly do a Zoom standard. That would work as well. We do know that we don't need any negatives, so I tend to try to focus in a little bit more when that's possible, but Zoom standard would definitely work, and hopefully I have that function typed in accurately. So in order to adjust our window, my students are pretty used to this by now. We press our window button. We know our domain, I was told 2 to 9, so I'm going to just go a little bit smaller. I'm going to go 1 to 10. I like to go a little bit beyond usually just so I can see it all. I'm going to make my X scale 1. And then our range is 0 to 5. Again, I just want to go a little bit beyond in both directions. So I'll go -1 to 6 and that'll be fine. Once I have my window set, I just have my students press Zoom. Now we are looking for how long it takes for the temperature to go from 0 degrees Celsius to 5 degrees Celsius. So we don't want the students solving. That would be algebraically a big mess. We also don't want them to just trace because tracing may not be accurate enough. We want to find the X value, if you will. We want to find the X value where we have a temperature of 0, so that X-intercept. And then we also need to find the X value when we have a temperature of 5 degrees. So I'm going to start by finding the X-intercept. So our zeros or X-intercepts are under second trace. And I'm going to go down here to 0. And it tells me on the screen exactly what to do. I need to go to the left bound. That means I need to go on the left side of that X-intercept. So I tell my students, go near that X-intercept and press the left arrow a couple more times. I know that my graph has to go from a negative Y value to a positive Y value. So I'm on the left side, I'm gonna press enter. I'm going to scroll over to the right side, do the same type of thing, making sure that I have a sign change in those y-intercepts or those y values. Press enter, and I just press enter for a guess. Now, the nice thing about the calculator, I don't actually need to write that value down. That x value that we just found is currently stored as the letter x, not to be confused with this variable x, but the letter x, this green x. So in my home screen, and I am bouncing back and forth here, my students have become really used to this, but they're doing it on their own too. I'm going to go back to the home screen, and that x value, if I press the green button and press where the x is, I'm going to press enter just to show you that it was the value that we just found. That's the x-intercept value, and I'm going to store that as the letter A. Might as well. So I'm going to press the store button, which is to the right of the 1, and then alpha and where the A is, and press enter. So anytime I need to use that letter A, it's stored there. I could certainly write it down, and some of my students definitely will. Some of them will just use the calculator so they don't have to mess with it. Now we need to also figure out where that rational function intersected this 5 degrees Celsius. So similar to how we did it with the first FRQ, we're going to go into our y equals and put that 5 in, and we're going to find the intersection of those two graphs. So I did second trace. I'm going to go down to intersect. And now I'm just going to arrow over until I'm near that intersection point. And I'm going to press enter 3 times. So it goes from the first curve to the second curve to a guess in case I have multiple x-intercept or multiple intersection points. And that x value there, that 7.7001-ish, is again stored as the letter x on my calculator screen. So I'm going to go back to that home page. And now I'm going to do the difference of those. I need to figure out how long apart or how far apart they were. So that letter x, that 7 and change that we just had, minus the letter A that I just stored, which was the x-intercept value, gives me now my answer. The answer is D. And it was some button pushing, but my students have become very familiar with it. So I find as I give my students practice problems and we see different problems, they're starting to get more and more comfortable, not only with the function definition, with the variable definitions, but they're starting to become more and more comfortable with, going back and forth between a graph and this home page and doing the calculations right there on the screen. The store button is right here next to the number 1. So I used the solution value and I pressed store. And I didn't have to restore that x value that I just found the intersection of because it was already live. Every time I recalculate something on the graph, it stores that latest x value as the letter x. So it really allows my students not to lose track of things. They don't have to write things down and then go back to their screen and write things down and go back to their screen. They're able to do it right there live on their calculator, which is always in front of them. We've got one more quick free multiple choice question that we're going to tackle with the AP4. And then we're going to kick it over to Karen for FRQ2. And so this is also from our CED. And we can see in this one, we've got a table. It asks us specifically, should be a real fast one for our students. It asks us specifically to find an exponential regression. So regressions are a big deal in this class, obviously. And then to evaluate that. So in our table here, I'm going to go back to my stat list, just like we did before. And I'm going to type in these values. Sometimes my students will clear out those values. Sometimes they'll just write on top of them or type on top of them. So I have 4 x values. And I can see right now, and I'm showing you this for a reason, that after I get to that last one, I still have a remaining value. And so I need to press the delete key, which is up near the top there. And you press the delete key to delete that out. The clear won't take care of that for us. And we do need to make sure our lists are equal here in length. So I had a little extra value there. I just pressed the delete key and it's gone. Now I'm just going to go ahead and in my L2 type in real fast those output values. And then we're ready to run our regression. The regression is an important feature, and Karen will show it to you on the Nspire for our FRQ2, which is partly why we chose this multiple choice to look at. So once we have our data in there, we're going to go into our stat and we're going to go into calculate. And there's a whole long list of regressions here. And down at the bottom, next to number 9, we do see an arrow down, which means that there are more features down there. I tend to be a person that actually arrows up to get to the bottom of my list. And the more that my students have seen me do that, the more comfortable they become doing the same. Some of them actually memorize the numbers that they're next to, but I always arrow up, and now I can see that exponential regression is right there. Now, with our regressions, this works the same with all of them. You select your 2 lists. Mine are usually in L1 and L2, so usually I don't have to fumble with that. I tell my students, even if you don't think you're going to use it, store the regression equation. Just get in the habit. We want to be super, super accurate. So once I scroll down to score regression equation, I'm going to press alpha trace, kind of like I did at the start FRQ1. I type in Y1 and I press calculate. And the reason I do that is because anywhere I am on my graphing calculator, that function that we see right there is saved as Y1. So I don't need to use my graph here. I'm going to go ahead and just evaluate that regression at 1.5. So I'm on the calculator screen. I'm going to press alpha trace again, get my Y1. I'm going to evaluate at 1.5. Oops, 1. Excellent, clear that, I apologize. So alpha trace, do that again, Y1. And I'm going to evaluate at 1.5. And I'm going to press enter. And now I see my answer. And regressions are a big deal. So Karen's going to show us how we use regressions as well as a few other features on our Nspire. So Karen, I'm going to kick this over to you.
All right. Thanks, Katie. While we're switching over to my screen, I also wanted to really emphasize that students on this new hybrid exam will have some different challenges, of course, by seeing all of their questions on screens, but they'll also have some different opportunities. And so it's really important that you stress to your students that even though after FRQ2 they lose the calculators, they still get to work on questions 1 and 2 in their answer booklets if they want to. So it's important that when they get their first questions and they're looking at them, they're making sure that they use the calculator for the things they need. And if there are some things that they can maybe address later after the time is gone for the calculator, they can go back and work on those. So that's an important thing to know and to communicate with our kids. So we are ready to take a look at FRQ2. This is an FRQ that I took from a book called Fast Track to a 5 that was just published this year by Kelly Hemmerling and Chrissy Ricketts. A lot of great questions in there with detailed solutions and all of that. And so one thing about FRQ2 is it's always contextual. And so in this particular problem, we have a wildlife biologist who's studying growth rate of lemurs on an island near Madagascar. So we know that in 2020, which they're telling us is time equals 0, there were 117 lemurs on the island. And in 2023, there are now 338 lemurs. So this is the thing that your students will need to look for in FRQ2, because there will be 2 ordered pairs, 2 data points in the text, and they may not be very obvious, but they have to be found because that's step 1, right? So then the next thing we find out is that the number of lemurs on the island can be modeled by a function L, which is given by L of t equals a times b to the t. So we have an exponential model for what's happening with this population growth on this island. And L of t is the amount of lemurs on the island during the year t. T is the number of years since 2020. So the first thing that students will always be asked to do in FRQ2 is to use the data that they are finding in this contextual situation to write 2 equations that can be used to find the values for A and B. So this isn't really so much a calculator question here, but it is important to emphasize that finding those first 2 points is really going to open the door for the entire FRQ. So looking here, we see that at time 0, we had 117 lemurs, and at time 3, we had 338. So those are the 2 ordered pairs that the students need to identify. And then we're going to put those values into our model. So the output is 117, the input is 0, and the output is 338 when the input is 3. Now, you probably could solve this algebraically without too much trouble. Taking a look at that, we see that b to the 0 would be 1, so we already know that a is 117. However, we are going to take a look at how calculators can help us visualize. And I've done a lot of reading on brain research, and believe it or not, when we do mathematics, we would think a very analytical part of our brain would be lit up, but it's actually the visual part of our brain that's lit up when we do mathematics. So for that reason, being able to see what's going on is oh so important. And so that's what we are going to make happen in this problem. So the first thing I'm going to do is go to my TI-Nspire, and I'm going to create a new document. Oops, hold on here. Let's go home. Sorry. There we go. And we are going to put these 2 points into a list. So I'm going to open a list and spreadsheet page. And even though this isn't really a regression problem and can be done other ways, I would like to get a visual of what's happening. So I'm going to say that time is my input, and we're going to enter our 0 and our 3. And then in the second column, I will have my lemurs, and I will enter my 117 and my 338. Okay, so now let's go on to the next part of part A and see what it is we need to do with this information. Oops, what? Let's go back, sorry. There we go. All right, so now that we have these ordered pairs in place, the next thing we're asked to do is to find the values for A and B as decimal approximations. So this is definitely a calculator sort of question. But as we mentioned, you could solve with algebra if you wanted to, but I would like to have a visual. So what I'm going to do is create a scatter plot of these 2 points. So it's not much of a plot, but I really want to see them. So I'm going to add a page to this document. And to do that, I just do Control Doc, and then I add number 5, the data and statistics. So there are my 2 points, but they are not really tied to any ordered or to any axes yet. They're just floating in space. They're waiting to know which is my input and which one is my output. So I'm going to come down to this horizontal axis, and I know that time is my input variable, so I'm going to choose that. And now I have a dot plot starting to become a graph. And now we go to our vertical axis, and we see that the lemurs should be the output. And now I have what's going to become my exponential curve eventually. So now that I'm here, I can see we have growth obviously happening, but I would like a function to model this. So to do that, I'm going to Menu, and now I'm going to Analyze. And once I'm in this menu, we go down to Regression, and we see all of our different options. So just like Katie did when she was creating a regression model, we're going to choose the one that fits what we need, and we are looking for something exponential. So we're going to choose an exponential function, and lo and behold, there we have it. So I now know what the value of A is, 117, and I also know the value of B, which is 1.424. And we would need to go to those 3 decimal places for accuracy. But the great thing that has just happened is I now have put an equation into this Nspire, or it's generated one for me. So I can now use this just like Katie did to do all kinds of other things that I might need to as I move further into this FRQ. So let's see what comes next. But before we do, I want to mention a couple of things about using regression in FRQ2. This particular question was beautiful for using regression. The points fit right into our exponential model, and we're good to go. But I want to take a look at some situations where regression is appropriate and where it isn't. And I want to cite some examples that we have in AP Classroom, also in the CED. So in our AP Classroom practice exams, we have 3 that are housed there right now. Actually, all of those exams have an FRQ2 where using regression would be appropriate. In exam 1, we have an exponential model. Exam 2 has a quadratic model. And exam 3 has, it's actually a piecewise function, but the piece we would be working with is an exponential model again. So all 3 of those, you could definitely do the way I just did this example problem. When you look at what the example is in the CED, or actually on the 2024 exam, those are natural log functions that have a lot of transformations happening. We have vertical translations, we have vertical dilations, and so in those cases, using regression is not quite as appropriate or simple. So it's kind of a situation with your students that they'll need to be able to look at what's given and decide what is the best approach. Okay, let's get back to FRQ2 because our time is going quickly as it always does. So our next question, now that we have our function, is asking us to use the data to find the average rate of change in the number of lemurs as a decimal approximation. So we are looking for that average rate of change that we have been doing since the beginning of the course. And again, it says show the computations that lead to your answer. So that was not there last year, but this year students will have to show what they're doing. And then we want to interpret what we have found. So students are in test mode and they're stressed and they're likely to make little mathematical mistakes when they try to do basic computations on a page. So when they have that calculator, they want to use the calculator. So we're going to come back to our Nspire, and I am going to want to use this function we found to find my average rate of change. But right now, this function doesn't have a name. It's just y equals. So I am going to create now another page. And this time I'm going to make a graph page. And what I would like to do is make my f1 of x be that regression function. But instead of having to remember what the numbers were and copy them down, I can actually find that equation if I go to my vars button. And here we have stat regression equation. And all I need to do is put in my input variable. And I have now another graph of what we just saw on the last page when we had our scatter plot. Now you might be saying, yeah, but where's the graph? I'm not really seeing it. Well, this is where I have to practice with students a lot to get them to think about, well, what kind of window makes sense? So even though, yes, we have all kinds of zoom options, just like the 84 does, I would much rather have my students thinking about the context and figuring out a window that makes sense. So I'm going to go to menu here, and I'm going to go to the window and go to window settings and say, what makes sense here? Well, we're talking about from time 0, so really we don't need to be at -1 or -10. Let's make that just -1. And as far as how far time goes, well, we know we're going from time 0 to 3. Let's leave this at 10 for now. We really don't need negative y values either because I don't know what a negative lemur would look like, but probably not anything I'd like to see. So we'll go to -1. And then for our max, this is the key right here. So our y max, we remember that we had the point 0, 1, 17, right? So what we need to do is actually be higher than 117. So let's do 250. And now I'm seeing a graph that's a little bit more exponential looking. I probably didn't need my axis to be way out at 10. In fact, I might change it quickly, but for what we're doing, we're okay. So remember what the question was. Let's find the average rate of change. I'm going to do this on a calculate page. So yet again, I add another page. This time I'm calculating. And now what we're going to do is use that function we are storing to then find our average rate of change. So I'm going to first of all create a fraction template just like we did before, and I'm going to do control divide to make that happen. And so now I'm going to pull up my function. Remember it was F1. So I'm going to type F1 of 3 minus F1 of 0. And then I'm going to put that over 3 minus 0. And there we have our average rate of change. And that was pretty easy, and we didn't have that danger of miscalculating on our own. The calculator did all the heavy lifting for us. So coming back to our question, we have our average rate of change with work, and then we can also interpret what this means. We have found an average rate of change that is positive. That's telling us that our situation is increasing, the L of t is increasing. We also know from what we've seen, it's increasing at an increasing rate because it's concave up, but that wasn't our question. And then we also know that this is valid from 2020 until 2023. Beyond that, we don't really know what's happening. But let's move on to the next part of the question and we'll see what's happening. Okay, so now that we are here, we figured out what's going on with the average rate of change. They're saying, we can use this average rate of change beyond t equals 3 if we want to. But if we do, are these estimates found using this average rate of change less than or greater than what the model is saying? Well, that's a lot of words to hammer through, but maybe if we can see it, we might be able to get a better idea of how to answer this question. So what I'm going to do is think about my graph again, But this time I would like to see that average rate of change modeled as a line, because we already know that at time 0 we have 117 lemurs. We now just found our average rate of change, which is 73.6667. So let's make a line happen. So I'm going to go back to my graph, which is at tab 1.3, and I'm going to hit the tab button. That's going to bring up F2 for me. I'm going to graph the equation of this line. So we're starting with 117 lemurs, and then we have our slope, which was 73.667. Oh, and what did I do? Kids do this too. We forgot all about the x. That's okay. Just go to tab, bring the equation back up, and let's put the x in. There we go. So now we are seeing our average rate of change modeled as a line, and now it looks like my window is really not very appropriate anymore. So I'm going to go back to my window, go to my window settings, and change that Ymax to something more like 1,000 so I can see a bit more. And there we go. So this is a nice visual of what's happening. Now back to the question, they wanted to know if I get past that point where t=3, and we try to use the average rate of change to make approximations, will they be bigger or smaller than what our model says? And looking at this picture is very clear that the average rate of change is going to make a prediction that is smaller than what L of t does. And so we can see it right there. As we explain this, we can talk about our average rates of change with a line being much smaller than with an exponential function. So again, the visual is the win. All right, final question here that we'll talk about is part C. And they're telling us that, we have this island and these lemurs are populating this island. And eventually we're going to have to do something about that because otherwise they'll just go out of control, right? So what they've decided is when the population reaches 1,500, then we're not going to be able to use this model anymore because they're going to have to do something with this growing lemur population. So how could this restriction, this 1,500, somehow be used to determine what our domain limitations are? So I know our time's getting really short, but what I'm going to think about here is what would happen if I were to put 1,500 into my graph? So I'm going to go to tab one more time, and this time I'm going to put in 1,500. And of course, that's off my screen, so I'm going to have to do a quick window adjustment again. And the more you have your kids going to window settings and making those adjustments, the more comfortable they get. So now I see where 1,500 is. What I would like to know is, when does this happen? When are we going to get to 1,500? So we go to Menu, we go to Analyze Graph, and we look for an intersection. And because I have 3 graphs on the screen, it's asking me which ones do we want to look at. So I definitely want my black line and my blue curve. I'm going to set my bounds, and there it is. So at about 7.214 years after 2020, we're going to be at that point where we have to do something about the lemur population. So to kind of wrap up what I'm going to skip this multiple choice question. So to wrap up our takeaways, it's so important for students to be able to visualize things when they're solving mathematics. And the way we do that is by bringing the technology in as often as possible. So whenever you promote technology as a means for problem solving and visualization, that gets them more comfortable with what tools they have. So the things we've looked at tonight were especially storing values and storing functions and being able to pull them up whenever they need them, being able to find intersections, extrema, roots, and using those, creating graphs and reasonable windows and being able to look at a function and know what window you need. And then of course, regression, which is the best way of modeling when data in a real life setting is provided. And we didn't talk about residuals, but my students are becoming it's a natural thing for them now to say, let me check the residual and see how good it is. So Katie, anything you'd like to add in before we have our webinar drawing?
No, I think we tackled a lot of content tonight.
Good.
So great job. I wish everyone the best. And we're going to hand it over to Mike for our webinar drawing and our wrap up here.
Awesome. Thank you. Thank you. Before I share the webinar drawing, one thing that I do want to share from our website, education.ti.com. Let me share my screen real quick. We're really excited that we have our summer workshops are posted. And so just to kind of get a look for if you want some additional professional development this summer, what we're offering, if you go under educators and then slide over to professional development, and then scroll down to T-Cube summer workshops, or there's also regional summits where also you can get some additional PD, fun to check out. So there's a whole bunch in our 2025 lineup. A lot of it's virtual, some are not, but lots of stuff that you can check out if you're looking to get additional PD this summer. And if you want more of that information, I actually have a slide in my slide deck about that. And I'm glad this came up because I do want to mention that there is some additional AP Precalculus, AP Calculus, AP Statistics, exam info coming up. We're taking next week off, but the following Tuesday, so 2 weeks from today, we're doing another T-Cubed webinar, and that will sort of give you the ins and outs of the upcoming big AP exams, AP Pre-Calc, Calc, and Stats. So do me a favor and join us back in 2 weeks. All right. Tonight's lucky winner for our webinar drawing is Victoria Rizzo. So Victoria, congratulations. Start thinking about which graphing calculator you would like to receive, and I'll be reaching out to you in about a day or so. To receive a certificate of attendance, as well as a link for the documents for tonight, go ahead and click the link in the chat window. And just as a reminder, the documents link contains my documents of that PowerPoint that we're looking at right now, along with the PowerPoint that Karen and Katie put together as well. So thank you so much for checking those out. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. If you need to get a hold of us for any reason, any questions or problems, feel free to give us a call or send us an email, 1-800-TI-CARES or TI-cares@ti.com. And you've probably heard me talk about this before, but I just can't stress enough how important it is. When you leave the webinar, you automatically get a follow-up email or follow-up screen, and that screen actually will have a few questions that let us know what we're doing well, what we can improve on, and almost just as important, what do you want to see in the coming weeks as we plan our future events? So please do share your thoughts in the post-webinar survey. Huge thanks to Katie and Karen for everything they put together and shared tonight. So thank you so much.
Thanks for having us, and good luck to everyone on the AP exam.
Yes, have a great 34 days.
Thanks so much for joining us. We'll see you back in 2 weeks. Have a great night.